Hey, Goran.
Hi, Ungo. Hi. How are you?
Hi. Good. Same night after I know we continue RFEM.
Yeah. We continue with
Mm-hmm.
our RFM session.
So,
So maybe what I will share my screen and
mm-hmm.
we can we can start.
Mm-hmm.
Okay, just a second. Please tell me when you can see my screen.
Yeah, I can see.
Great. Okay. So maybe just uh, short
Mm-hmm.
summary
Mm-hmm.
what we saw until now.
Mm-hmm.
I think maybe I have also already opened some window for our last session.
Mm-hmm.
No, what we're speaking about user interface, about the modeling part, about surface tool, uh, beam opening, mostly based on modeling,
Mm-hmm.
some basic part for supports. Last time we showed some interesting part about importing elements from uh,
Mm-hmm.
DXF
Mm-hmm.
file or from something exported from Rhino or
Mm-hmm.
dealing with IFC
Mm-hmm.
inside new RFM6. So I will take a look. What was okay? There was some yeah part uh, where we stopped.
Mm-hmm.
So maybe just go. Maybe just this time let's go to see if we something missed and maybe show some uh, support definition and loading
Yeah, sounds
loads
sounds good.
load definition load combination and
Mm-hmm.
in this part.
Mm-hmm.
So maybe and so after this part we can maybe summary and finalize our preparing those basic elements
Mm-hmm.
before calculation.
Mm-hmm.
So
Mm-hmm.
uh, just for maybe short replay on basic tab
Mm-hmm.
on base data we have on
Mm-hmm.
uh, standard tab
Mm-hmm.
we have a group of national standard
Mm-hmm.
and code for calculation,
Mm-hmm.
which will be used for load case classification
Mm-hmm.
and for combination wizard.
Mm-hmm.
In our example, here we will stay by standard definition, but it's easily to change if you need some other
Mm-hmm.
national annex
Mm-hmm.
for designing, or if you need some other standard group,
Mm-hmm.
uh, uh, s- depending on your country
Mm-hmm.
in which you use this software. Okay, so maybe just for the beginning also to show here we also we show this basic property palettes, and here down we have some load cases, load
Mm-hmm.
action, design situation, load combination. So maybe just for the beginning,
Mm-hmm.
let's create just a simple beam.
Mm-hmm.
We will give some properties. We will say this is the beam, standard beam section. It's 9 meter. Okay, we have some already section and material
Mm-hmm.
assigned
Mm-hmm.
for this beam. Okay. Remember, I will say here design properties are not important for me in
Mm-hmm.
this moment. Okay, and define uh, I will define support
Mm-hmm.
for this beam
Mm-hmm.
uh, at the beginning, at the end.
Okay.
So we can use standard tab on the top
Mm-hmm.
for assigning nodal support,
Mm-hmm.
or we can choose our node,
Mm-hmm.
right click, right click
Mm-hmm.
mouse, and we can click edit node
Mm-hmm.
one, and here we can then choose
Okay.
support.
Mm-hmm.
This node has support,
Mm-hmm.
and here we can choose support.
Mhm.
So I can click easily new support, and now I can choose support from already defined
Mhm.
support, and I can create new one
Mhm.
if I need something else.
Mhm.
Statically, there are already presented some most usually types of support,
Mhm.
node supports. So maybe just for beginning, we can explain this is the fixed node.
Mhm.
So what it means. So if we have this kind of nodes
Mhm.
here, here,
Mhm.
so that means it's completely fixed.
Mhm.
And if I take the simple cantilever,
Mhm.
that means it can take moment and vertical and horizontal force
Mhm.
in
Mhm.
this option.
Mhm.
So that's first support. Second support is the support which we can use as hinged or pin.
Mhm.
This one for us, that means it can transfer only horizontal vertical force.
Mhm.
There is no
Moment.
possibility to take moment.
Mhm.
And now these are combination.
Mhm.
This is free in both direction.
Mhm.
This is fixed in x, in y,
Mhm.
or it's vertically
Mhm.
allowed
Mhm.
transformation.
Mhm.
And there's also some option to define spring
Spring condition.
constant, yeah, spring condition if you want.
Mhm.
Maybe it's not in our case
Mhm.
important now to talk about this,
Mhm.
but we will define two different
Mhm.
on the first part we will hinged, and at the end node we will define uh, support which is characteristic for simple beam.
Mhm.
We can this is okay.
But can you define also rolling support like
uh, rolling yeah this
mm,
yeah this is the some kind of because
because we keep the okay freedom. Yeah, it depends on where
in
we lock the freedom of
yeah
the yeah. Mhm.
this has
Y transition
that
is
y direction
mhm.
is allowed
Mhm.
in this case. Uh, this is y
Mhm.
transition is
Mhm.
allowed,
Mhm.
x transition is allowed,
Mhm.
and here are both transition allowed.
Mhm. Mhm.
So we cannot in this case we cannot put
Mhm.
both transitional load because it will not be statically
Mhm.
correct.
Mhm.
So when we define, for example, simple beam,
Mhm.
let's see. Uh, let's maybe create just maybe one slab parallel to this.
Mhm.
Okay, I will create. Uh, so let's okay. I will create some. I will create some kind.
Mhm.
Doesn't matter.
Mhm.
So, okay. I will use some interesting option here.
Mhm.
So I will select all my lines
Mhm.
which I draw in 0, and I will say extrude line into surface,
Mhm.
and I will extrude this line into standard surface
Mhm.
thickness 20, 30 millimeters.
Mhm.
Material is this,
Mhm.
and I will say please extrude it to me for 3 meters.
Yep.
So apply. Okay, so I get my surface, and I will use this from last time
Mhm.
known option
Mhm.
select boundary to create a slab.
Mhm.
I will say okay. I will generate boundary, and I have also
Mhm.
slab.
Mhm.
In this case, I want to define line support.
Mhm.
I want to define line support. Okay, I can also go here,
Mhm.
assign line support, and I can choose. Okay,
Edges.
I
Yeah.
want, yeah, I want just take those lines.
Mm-hmm.
Okay, and here I can define same way as
Mm-hmm.
I define the nodal support
Mm-hmm.
for simple beam. I can define it also under the walls,
Mm-hmm.
or I can choose edit and create
Mm-hmm.
one which is okay for me.
Mm-hmm.
In this case, this is just fine for me.
Mm-hmm.
Maybe if I want to change the spring constraint, I can give it I can define those vertices here,
Mm-hmm.
but also same as previous video.
Let's try also. Maybe we can later
Uh,
try one
maybe we can
foundation. Yeah, foundation, and then give the spring
yeah
condition. Yeah.
maybe we can do this
Mm-hmm.
option or yeah, good option. So
Mm-hmm.
let's do something some other
Mm-hmm.
case. I will I will go here.
Mm-hmm.
I will say please copy.
Mm-hmm.
We show this copy option.
Mm-hmm.
We can use same option to
Yeah.
move
Yeah.
our things or create copy. If I say create copy,
Mm-hmm.
okay, let's do this for one and let's go in 10 meters in this in y direction.
Mm-hmm.
Okay, I will
Delete
I
it.
will delete those and I will create on same place some sorry, select boundary, thickness. I will create new thickness for foundation slab. Let's make this 40 centimeter, 400 millimeters,
Mm-hmm.
40 centimeters. Apply OK, OK, and let's create it
Mm-hmm.
in this place. And let's give here
Area
some,
support.
yeah,
Mm-hmm.
area support. Okay, in this case, I can see. Just a second, I will show. I will click here. Let's turn on visibility of those surface for systems.
Mm-hmm. Mm-hmm.
So, okay, I see it's global
Mm-hmm.
Z
Mm-hmm.
on slab is down.
Mm-hmm.
Okay, uh, let's get, let's take the support system. Okay, just a second. Z. Okay, but I would like to create new one.
Mm-hmm.
I would like to create new one,
Mm-hmm.
and I want to give some. I want to give negative. I want to give not Z. Not, I don't want this.
Mm-hmm.
Just a second. I want to define spring constant is this, and I want to define I want to define ux y fixed,
Mm-hmm.
and I want to define spring constant in
That.
z direction. For example, so this this depending about soil condition, you
Mm-hmm.
know.
Mm-hmm.
For example, if we have really bad soil, this is some part where geotechnical engineer
Mm-hmm.
are taking in
Reporting. Yeah.
charge.
Mm-hmm.
Yeah, they from we taking this value from these reports, and it's directly connected with the settlement
Mm-hmm.
with of foundation.
Mm-hmm.
So if just for some range of values, if the ground is very bad
Mm-hmm.
and it's not really good for foundation, this can be approximately 3 to 5 thousand
Mm-hmm.
this spring,
Mm-hmm.
this K
Mm-hmm.
word, and if it's for example rock
Mm-hmm.
on the ground and it's very good for foundation, this value can be also 50,000 or 45,000 or 60,000, for example.
Mm-hmm.
It can be greater, it can be lower, but approximately I'm just giving some example.
Mm-hmm.
So I will take here 15,000 for a spring, and what can I see? Now I get under my slab.
Mm-hmm.
I get the second. Did it change? Sorry. Okay.
Mm-hmm.
You see, we get,
Sprinkler. Mm-hmm.
yeah, we get on the side
Mm-hmm.
some spring condition
Mm-hmm.
in this. So it means when we put some
Mm-hmm.
forces
Mm-hmm.
on it, our foundation will not give 100% reaction from
Mm-hmm.
bottom. First, he will go a little bit down, and
Mm.
then it will react on this
What
force,
what
which will
about the
be there.
bedding option for the foundation slab?
Uh, how do you think it's it's happening just according
Mm.
this
Mm.
this spring condition, you know,
Mm-hmm. Mm-hmm.
uh,
Because in
because
sophistic we can set the bedding material, yeah? I think for the slab, but yeah, it doesn't matter.
okay,
Mm-hmm. But it doesn't matter because anyway we
yeah,
give support spring condition, so
yeah,
that's.
yeah.
Mm-hmm.
So what's possible to do, you know,
Mm-hmm.
if you make classically designing
Mm-hmm.
floor by floor
Mm-hmm.
statical calculation from some building,
Mm-hmm.
then you can put this spring constraint regular,
Mm-hmm.
and you will get the forces which you will transfer on another
Mm-hmm.
part of
Mm-hmm.
buildings, and at the end you can create the complete model of your
Yeah.
house
Mm-hmm.
with the spring condition
Mm-hmm.
for checking the foundation.
Mm-hmm.
uh,
So if it's a big project, you do substructure analysis, yeah, floor to floor. So in this case.
yeah, it depending it's regularly, you
Mm-hmm.
know,
Mm-hmm.
you have to find a way to check vertical elements, you
Mm.
have to find a way to check horizontal elements.
Do you
uh,
have this system in RFM substructure system that you can?
usually if we usually in RFM
Mm-hmm.
it's very good. I didn't check in RFM6 this option, but
Mm-hmm.
in RFM5
Mm-hmm.
there is the option to transfer load,
Mm-hmm.
transfer reaction from one model
Mm-hmm.
as loads in another model.
Okay.
So it's easily that you can separate
Floor.
each floor
Mm.
in separate model
Mm-hmm.
and transfer it.
Mm-hmm.
This is good because then it's easier for you to follow the structure.
Mm-hmm.
It's easier to control the load,
Mm-hmm.
and later if you calculating the long-term deflection, it's also uh, better for model. It's
Mm-hmm.
performance for performance model is much better.
Mm-hmm.
So maybe this is the we shown how to set
Support
all
condition.
those support condition, yeah, and now we can create some load cases,
Mm-hmm.
or even I can just make one more example because we will need it to show how to generate how to generate loads. if
Mm-hmm.
we have if we have for example some this beam grid of beams. So I'll here section. Okay, just section. Okay, it's okay for me if this. Okay, and I will copy this beam 10 times or 5 times. It's okay, and I will say step links, link load with line, link loads with member. Okay, take this member. Okay. Uh, uh, yeah, 2 times and just second. Okay. Yeah, yeah. Okay. Uh, this is I just want to get this part, and I will choose all my nodes and put just a regular spring under because I want to put some load on this. What is very nice here, because I don't need think what I don't really take care what I selected. When I select this, if I want to choose all nodes, I can just click here and I can choose node, edit, I can say support, yes, please give me this one. Okay, and I have support under all of my parts.
That's great.
So yeah, this is, I think this is enough for the beginning. Now we can see how we will define our loads. So maybe if I go in load case in combination, if I click here, right click, I will get also those 1, 2, 3, 6 tabs up which shown, where can I see all my information what I need for defining this. uh, Here is the standard. We already say this is base properties. According these standards, he will automatically generated for us this load combination. uh, and now I can, if I go here, I can define load cases. So what are the load cases? Load cases are uh, different kind of loading, which will be used later as an action to create design situation. According to the design situation, it will be create action and load combination using them. So first and main is always the self weight. Uh, we know that all materials, all elements have some self weight, and we cannot forget. We shouldn't forget this option. So we can say self weight, self weight. How the software know, or RFM, that this is the self weight of elements according to the materials properties, because here we have active this option self weight. So this is first, we can say okay, just to show. And after we create this uh, load case, it will be defined here on top, and we can see it clear. So let's back here, and let's say let's define another one. So and this self weight is permanent, so that means that it's in action all time. And here stay some characteristic according the Eurocode, according to standard. So second load which I will create, I can automatically connect it with this in this part, this red part, that's imposed load, or load caused by usage of construction. And we can see here some different categories. They are also according standards. You can see here parts. First category is for domestic residential areas, category A. That means that here are the uh, um, here are the loads are a little bit smaller. There are smaller value uh, in correspond in if we take look, for example, category D, or some congregation C congregation areas, here will be the this load a little bit bigger than for if you're designing your own house, because for example, if we have some uh, storage areas or shopping areas, it's probable that there will be more people in same time. It can be more loads on same place in same time.
Mm-hmm.
But if you are at your home, probably there will no be
So,
that kind of
so this is
load.
talking about variable load, live load,
Yeah,
and the
live load. Yeah,
different
live load.
factors. Yeah,
Yeah,
different
yeah,
factors there.
live load. So we can stay by standard domestic. And for beginning, maybe we can create just these two.
These load case actions are already predefined by on the actions. Right?
Okay.
No? Okay.
On the design
Yeah.
situation, this.
No, no, no. Actions. because
Action.
we choose action category. This is already provided by this template, right? This like domestic or shopping.
Those are predefined
Yeah, from the Eurocode. Yeah.
from the Eurocode, yes, and they are incorporated in all software for calculation. We created the permanent because that's always here, and live load is also always here. Uh, Two more category which are for our example now maybe good to show is how to define snow and how to define wind action. But we will create now just two of those to show how it works, and then we
Mhm.
will
Mhm.
go to defining snow and wind. So if I want now, I can see also here I have self weight and load, and here on the side I have loads. Here is in this pane I can choose to create nodal loads, line loads, member loads for category or load case self weight.
Mhm.
So for example, I can create
Mhm.
member loads
Mhm.
for this uh, self weight.
Mhm.
I can assign it to member
Mhm.
this.
Mhm.
Okay, and I can say, okay, it's a force. Its distribution is uniform. That
Mhm.
means it will be
Yeah, uniform.
distributed uniform
Mhm.
uh, through complete member,
Mhm.
and it will be in that direction.
Mhm.
So here is the load magnitude.
Mhm.
Uh, but I already say that this
Self weight.
self
Yeah.
weight is
Mhm.
self weight.
Mhm.
What can be possibly here added? We can maybe add some additional. It will be not a self weight. We should create
Mhm. Mhm.
another load case
Mhm.
for additional permanent
Mhm.
action,
Mhm.
like flooring and
Mhm.
all the stuff which
Mhm.
are which
Mhm.
are here.
Mhm.
Uh, but we can maybe just, for example, put it here. It's not too much important. We can say, okay, let's put here 1 kilonewton
Per
per
meter.
meter.
Mhm.
Okay, we will get. Okay, sorry, it's a minus because it's
Mhm.
upward.
Mhm.
Okay, it will be here,
Mhm.
and also we can do it for live load.
Mhm.
What we should do, we should change the position. We should choose live load,
Mhm.
member load, new member load, and okay, same option. We will now say minus and a half. I don't know,
Mhm.
member this. Okay.
Mhm.
Uh,
And this the input value 2.5 kilonewton per meter. This is based on you looking at the mostly code, no Eurocode, and there
yeah.
defines this value, right? You just
No.
no
Those values are defined according to analysis.
analysis. Okay.
Yeah, analysis. For example, we can take look. Uh, so
Mhm.
uh, I I have my I have my beam
Mhm.
here. Yeah, and this beam, for example, is in space somewhere
Mhm.
where the span is in this direction.
Mhm.
Uh, is this direction is 3 meter.
Okay.
3 meter. So on this beam, it will take, for example, we saying half span
Mhm.
from this side
Mhm.
and half span for this side.
Mhm.
So approximately 1.5 meter will
Mhm.
go here.
Mhm.
So this is one part. And now if we take in consideration, for example, if we have this situation there,
Mhm.
down under is okay, maybe we can say it's a rectangular beam
Mhm.
standard, and above is some
Floor.
floor,
Mhm.
yeah, with this
Mhm.
with this
Architectural finishes. Yeah.
yeah, architectural finishes. Okay, we can say now then this is for example 10 centimeters,
Mhm.
and our slab
20.
which is 20.
Mhm.
Okay, now we will say for example those
Mhm.
if this slab is
Concrete.
reinforced concrete,
Mhm.
it's 25 kilonewton per meter cubic, multiplied with 0.2, it will be 5. Yes, it will be 5 kilonewton
Okay.
per square meter, and we will multiply it by 1.5 meter, 1.5 meter, this, and we will get 7.5 kilonewton per
meter. Yeah.
per meter length. So that means if we take weight of this slab, this will be 7.5 kilonewton per meter on this beam, vertical force distributed.
So the calculation is like 25 kilonewton per cubic meter
Cubic meter
divided
is
by the thickness.
weight
Yeah.
multiplied by thickness.
Thickness and in in meter.
Meter, yeah.
And then that's the 5 kilonewton per square meter, and then you need to multiply the area of the span.
Area in which from which this beam taking action. So what's for us when we calculate first of our job is to make some this layout plan with overview of construction element and some plans with loading area and loading analysis. And after that we define those characteristic loading for each type of element and each type of slab. And we after we done with this job, then we going into our structural model for calculation.
But this 25 kilonewton per cubic meter, this is based on the material, right?
This is based on material. If we take look, that means that 2050 kilogram per cubic meter is the weight of concrete. Reinforced concrete. Reinforced concrete. Not regular concrete is 2040 kilometers. It's just 100 cubic. So those are some values. And before we done this classically using some Excel tables, now it's a bit maybe easier because we can actually take more accurately those elements from BIM models and calculate more precisely. So, but there is some norms and some standards also which we also take in consideration. So because in our example, it's not important. It's just for showing. It's just for presenting. But we can explain every time how we get some load. It's not a problem. And when I have, for example, just this loading, I can say here is the option just for calculating. It will tell me there's no result from self-weight. We want to start calculation. I'll say yes. Assign the surface concrete durability surface 5-6. Okay, there are no some support design properties. Sorry, this is also from new part. Deactivate for calculation. I'll try also deactivate this for calculations. Not for now. Okay, the same. Cannot have
concrete surface number, concrete durability number, also concrete durability.
Concrete durabilities.
This is okay.
Okay, let's go. But he asking us. Okay, let's and let me see. Show result. Please check the table of errors and warnings. Stiff pneumatic structure unstable.
It's unstable.
Okay. Let's
fix it.
No. It should be probably.
Fixed condition.
Sorry, it's wrong direction. Let's put it. Let's put it possible to go in this direction. Okay. Sure.
So calculation is just simply that with the eyes.
How? It's 9 meter.
No, it's
Oh.
9 meter. It's too long, maybe.
Yeah, it's for this. For this, it's a little bit. Let's move it. Create copy. Let's move installation in 6 meter. Okay. Okay. Up. What did I make? Okay. Let's move it for 4 meters. Okay. Try it now. Because it's not big. It's not big loading here. Let's think here. It's okay. We take. Okay, let's take this one. This is classic, and let's know. Here's I choose good. I choose good one. I don't know what's happening. Okay. Sorry. I think this one is. This one is correct. This one is correct, but I should fix
the rotation.
rotation. Yeah, this is sorry. I completely take over. Okay.
So it was unstable, and it doesn't.
Yeah.
Now
But
it's
it shouldn't be unstable, yeah, because it's really not too big span. And now here I can see. I can see.
Result of self-weight.
Yeah, self-weight. Here is some just regular global deformation, and here deflection in Z. It's 0.5 meters. Okay, 0.5 millimeters. So we can now calculate and check this according to code. Is it in limit area? Is it in allowed area? But first, then we should define the combination and all those other stuff.
But can you show the animation of this deformed geometry, or?
There is just a second. Sure, we can. Let's do like this, and now let's remember result. Just a second. Here's somewhere is deflection. View. Oh, sorry. Result. The option is numbers. Just a second. There is some deformed shape presentation. It's deformation. It's here. You think on this like sophisticated presentation? No. I don't think there's a similar option.
Okay.
To see deformation like this. What can I turn on? Invisibility. I can go to result. Result. Second, general. I can say here. There is option where I can define to show deformed
geometry. Yeah.
Members. Just small part. Loading value. Perfection. And now can I? Sorry. Support distribution. Loads. Surface.
Maybe on the members.
Members local deformation. That's just local strain stresses. No. Just a second. It's type of display. It's not separation line. various members with diagram. A second. Global deformation, and now I can say
Mm. Is 6 change a lot, like in this point?
yeah.
Really? Wow, crazy.
I haven't used the 5 version, then this is really being changed in or
Okay.
there.
But on the deformation, if you see on the deformation, like you have members up there, deformation, yeah, and section,
This
yeah.
yes, color and separation. Yeah, great. So you can present like here, and then you can here
But there
see
is no animation effect like sophisticated.
result display options. Yes. No.
But this is like a bit exaggerated deform, yeah. This, like deformation. This is showing it's. I mean, it's not realistic deform, yeah, for this self weight. That's exaggeration of the deformed geometry. No, it's not
Uh,
the real factor. It's kind of
you think it's
scaled.
scale? Yeah, it's scaled. Here is a general scale.
So you can
No,
make it to.
yeah,
Okay.
I
Okay.
can make it
How
to.
did you go there?
It's in here when you in control panel when their result.
Mm-hmm.
You can choose also in here in this option you can choose the scale
So
for
if you
deformation. If
so
you type 1,
one is
you know,
rear and then
you will not see anything. So if you go
Mm-hmm.
500, there will be deformation a bit
Mm-hmm.
bigger. So it depends how they
Okay.
want
Okay.
to present your results.
Mm.
I'm just kidding. But they're just
Okay. So one benefit, like say sophistic in this case, the graphical presentation is much more attractive in sophistic somehow.
I think there's also very good possibility
Mm-hmm.
to
Okay.
make a graphical presentation.
Mm-hmm.
Main part during the printout report, you can make really
Okay.
really nice graphic because
Okay.
this is really nice presentation. Also, if you want to show
Mm-hmm.
your
Mm-hmm. Mm-hmm.
but okay,
Okay. Sounds good.
I will.
Maybe we can continue next week. This more about adding more load cases and maybe load combination, and then see some more result in different way. Yeah,
Okay,
yeah.
okay.
Like
Maybe, yeah, maybe okay. It may be better to shorten this on
mhm,
supporting
mhm,
condition,
mhm,
some
mhm,
some basic view,
mhm,
and next week then we can finish the generating the snow load
mhm,
and wind load
mhm,
because there is very nice option
mhm.
to generate
Yeah.
snow load.
Mhm.
There's great wizard
Yeah.
also for this. So okay.
And is there any possibility you can show in the later in the session some maybe we can use one of our guidebook example
Mhm.
to just show simple like analysis in RFM6, you know.
You think complete building?
Or maybe you can simply build something
Yeah. We can create some.
something
Uh,
random like
yeah.
not complex just
So maybe I have an idea. Let's make this part with next
mm,
time.
mm,
Let's finish this
mm,
loading
mm,
loading part and load combination,
mm-hmm.
and after that let's create in one session,
Yeah,
maybe
yeah,
1 hour, 1.5 hour.
mm-hmm.
Let's make complete small building
Yeah,
with
exactly.
with
Very
all
simple
parts,
building. Yeah,
very simple building with some openings, with
yeah,
few slabs, some beams.
yeah,
Let's make complete
yeah,
complete model and analysis
yeah.
inside
And then
inside.
we show the report from that yeah,
second time.
yeah, second
We
another,
need one
yeah,
time,
yeah,
another, and so that means in 3 times we can finish it all up.
yep,
And then we will also be done with now our Rhino
yeah,
part, I think, and we can combine.
yeah, and then that is finished for Rhino and RFM basics, and
Yeah.
then we can move on to Grasshopper basic for you, and we can use after Grasshopper basic we can use this connection between RFM Grasshopper plugin
Yeah, yeah, yeah.
to RFM, and that's I think very exciting moment. Yeah,
Yeah,
yeah.
I can wait for it.
Yeah, and we can probably combine some Rabbit mode. Once we know now all this connection, we can combine Rabbit to Rhino to Grasshopper, and then RFM.
Yeah,
So
we can
there
make
are a lot of possibility we
full
can
potential.
plan for
Yeah.
that.
Okay,
Good,
great,
Goran.
great.
Thank you very much. Stop
Thank you.
recording from here, and thank you very much for your session. It's really useful, I think, for
Thank
the
you.
people. Thank you.